Okay, let's go ahead and go over at least the midterm study guide I've written up for you. First off, I have the midterm scheduled for February 29th or 28th during class. If you choose to take it online, you must get it complete by the February 29th by noon. So since we have a blended class, I'm just going to allow everyone to take it online if they wish. All right, closed book, no notes, no use of neighbors or internet. You can write everything on a 3x5 note card. So there you go. The easiest way to review for this is review all of your quizzes. Answers are discussed. We've discussed them in class, and I've posted them on GitHub. So you should be able to review all of the quiz questions. Some of the quizzes, or some of it will come from the quizzes, some of the questions. Most of them will be questions about Java and reading Java code and answering your question about the code. Like, what is its output? What is the problem with this code semantically? How can you fix this piece of code? What would be a better way to write this piece of code? Adhering to our OO principles that we've gone through so far. There's a section where I want you to stub out code for a design. Hopefully I've gone through stubbing. It just means that you will write the class and the function headings, but leave the implementation empty. So don't write the implementation of the code to the functions, just write everything else. So that's stubbing it out. We'll be going contents of, let's see, core Java, chapters 1, 2, and 7, and our object-oriented thought process, chapters 1 through 10. I will question you about Git, a little bit about UML, and memory management, static, stack, and a heap.
We can find those last few things, the UML and memory management, those are in the course.
Those are in the slides mainly. Git, UML, memory management, yeah, those are basically slides, but you can look up.
What kind of questions would be from Git, like how to do what we originally did on Git?
Yeah, I may ask you how a couple things about how Git works. Why are we using Git? Why am I forcing you to learn Git for this class? Just basics of Git. When I say basics, I mean basics. If you've been using Git so far, hopefully you should be ready for that question. UML, I think we've touched on it a little. We'll go a little bit more into class diagrams before the midterm. Memory management, hopefully I have harped on that the whole semester, so we're good with how that works. All right, so we got core Java 1 through 2, chapters 1 through 2. Remember, that's the practical book. So it's basics of program, common identifiers, reserved words, strings, or etc. on that. Strings, variables, and primitives, like strings and integers. We're ready to know the difference between a primitive and an object, especially about how it behaves with memory. So with primitives, with objects, where do objects reside in memory? A heap. And where can primitives reside? Usually on the stack, although you can have some of them reside on the heap if they're a member of a class. Let's see. Know the string class, what it is. It has a .link function. Understand the difference between double equals with string versus equals. What is the difference?
Equals sensitive.
Double equals.
Double equals sensitive. I mean, comparison.
Compares what?
The values of the string.
Does not compare the values.
The position.
The memory addresses.
The memory addresses of the string. So if you have two separate strings that both contain hello, when you do double equals, will that be true or false? False, right. But if you call dot equals, it'll be true. So make sure you understand the difference there. Because an object, you're really holding a pointer to an object, the memory location of an object, and that's why when you do double equals, you're just comparing the memory location. All right, be ready to evaluate Boolean expressions, if, switch, while, do. That's hopefully pretty clear. Understand how to create an array list, balance checking with array list, and the remove and add functions of an array list. So we'll be playing a little bit with the array list. Hopefully most of the exam will be, most of the exam actually will be from the object-oriented thought process. Be ready to take a problem and partition it out into classes, just a high level. I will ask you a very general question about If you need to write a simulator or something along the lines, how would you partition it out? I'm just making sure you can at least think in objects about how you would interact with one another. So when you see that question, know that there are plenty of correct answers. Understand how functions work in Java. Identify when it's a good idea to use inheritance or composition. Ooh, yeah. How do you know the difference?
The difference of when you use them? Or
Well, yeah. When should you use inheritance and when should you use composition?
Wasn't that the bottom up versus top down?
Right, bottom up or top down. That's one way. That's a good way to think about it. In a way. What's the relationship with inheritance versus composition?
Inheritance is
Inheritance is like the parent and working with like specific classes underneath it. Composition is like
more classes make up one class.
Yeah, more classes make up one class. So composition has a relationship. Inheritance is a relationship.
That's what I was trying to say.
All right. Identify when you use aggregation or association. We're going to go over that today. Identify good good interfaces and poor ones. Hopefully you've built some intuition about this. We're going to go over solid next week, which should bring that home even more about what's going on. Or we might do solid this week. Yeah. Be able to read and write inheritance hierarchies in Java and UML. Understand why polymorphism is useful. So examples are in Lab 4, which you have right now, and Lab 5, which I'll assign soon. Make sure you understand what extends does and be prepared to read a UML. Also understand what implements does. I need to fix that. Let's see. Modifier does be prepared. Understand interfaces in the list lab. We're going to get a list lab coming up soon. Identify what should be public and what should be private. So I give you some code and ask you, are there any problems with this code? The first thing you should check is, are everything that's private, should they be private? Is everything that's public, should it be public? Make sure you can look at it and tell me what's good and what's bad. And then chapter 7 of core Java. Be able to use an iterator. We'll hopefully get in that today morning. And identify why we're using iterators over standard for loops. And again, solid to be able to apply it to code. All right, so we still have a couple things we need to learn, but a lot of it we've already gone through. Oh yeah, here's UML. Again, just for clarity, be able to write a class from a class diagram. Understand why we use Kit. I'm not going to test your ability to use it during the exam, but basically understand what it does and why we use it.
Because you want us to.
Because I want you to. That will be a wrong answer. Know what data is stored in static, memory, stack, and heap. And of course, be able to answer the question, what happens when the stack meets the heap? What does happen when the stack meets the heap?
Stop.
Stack overflow, or memory out of bounds. I'm looking for, not memory out of bounds, out of memory is what I'm looking for. But yes, stack overflow, you can think of it that way, but more importantly, you're out of memory. All right, I'll be online through Blackboard, like the quizzes. Let's see. Schedule for February 28th during class. Online students need to complete their exam before the 29th at noon. Let's see, you'll have 120 minutes to complete it, but I will write the exam with the expectation that you'll complete it within 90 minutes.
What is the format of a lot of the questions? Is it mostly multiple choice or is it fill in the blank answers?
So in general, I have a giant matching problem at the beginning,
Okay.
and then the rest is short answer / essay.
Sweet.
Is that a good description of how they are? Pretty much? Yeah. Okay. Any questions? Are we all tired? Huh? No time? All right. Let's see. Let's go ahead and get that done.